Hi, I'm Stan Riddle with Acoem USA. Today we're going to talk about some important tools you need to use for calculating and finding an accurate running speed of rotating equipment. Knowing the accurate running speed, not just the nameplate data on an electric motor, but a really accurate 1x of the running speed is critical whether you're doing vibration analysis, whether you're doing balancing of rotating equipment. It is very important to know the accurate running speed, plus or minus 1% or less if you can get it. So we're going to talk about some of these tools and how you can use them to help you do your job, get more accurate data, get a more accurate analysis, and balance machinery more accurately using some of these tools. I'd like to spend just a second to talk about them if we could. So the first tool we're going to talk about is a laser tachometer. A laser tachometer simply just shoots out a laser beam with a counter. You'll use it in conjunction with a piece of reflective tape on the shaft or the disc or the fan wheel or whatever you're using as your target, and it'll just give you an accurate count of the running speed. A step up from that, and probably one of my favorites, is actually to use a strobe light. A strobe light is really just a light that will flash at an extremely brief duration, accurate rate, a lot like a timing light. If you've ever used timing light on an engine before, it will flash at once per rev, and we can adjust the speed in here, the flash rate, to give us an accurate running speed. You can also use our one prod Falcon or the SMC. Both have a built-in strobe light into the unit itself. So if you don't have one of these to carry around, you actually have one built into the back, and we'll go over that in a minute as well. But we're actually going to use a laser photo tachometer as well. Works the same way, but instead of us adjusting it manually or looking at a readout, it will actually input the running speed directly into a Falcon or an SMC. So we'll start out with a laser tachometer. Now we're going to use this little bench grinder here that we use for our balancing training. It is variable speed. I have no idea what speed it's going to start up to. I've just set the little adjustment on it. So we're going to start it up. It has reflective tape on here, and I'm going to use this laser tachometer. Now again, these are fairly inexpensive tools, just a few bucks honestly, but they're usually more than accurate enough to give you the reference as long as you have a piece of reflective tape. So I will turn this on. Hopefully you can see the beam striking there, and it tells me that the running speed is 3,253 RPM. Now I can get up really close to it, and I can get the same speed as long as I don't point it directly at it. If you get these really close and point it right up on top of it, sometimes you'll get a little feedback. It'll double or triple the flash rate. So you need to just play with this and adjust out a little bit. Start out fairly close. You can move it at a little bit of an angle. If you're off of it, obviously it's not going to give you the running speed because it doesn't see it. When I get back on here and let it settle out, it goes right back to giving us an accurate running speed. And I can move this back, honestly, with this one, and again, it's fairly inexpensive, but I can get back from this rotating element 3 or 4 feet and get an accurate representation of the running speed. So you have to be safe about this and be careful with what you're using. Obviously, I don't want to stick it in there and break the end off of it or get hurt or damage the equipment. So just be mindful that sometimes you can get a few feet away from this and get a very accurate, very repeatable running speed. Now I say repeatable within a couple RPM one way or the other. Part of it may be that I'm pitching this at a little different angle. Some of it could be this is a fairly inexpensive little grinder, and it may have a little bit of variability in the speed, but I can get it more than close enough to do accurate vibration measurements or accurate balancing if I were using this as a balancing tool. So the next thing we're going to talk about is a strobe light. Stroboscope, I guess, would be the official term, but in maintenance shops you'll hear them called a strobe light, and these things have been around for years too. They're excellent diagnostic tools. You can actually freeze or slow motion the machine with the flash rate to do some inspection while the machine's running. But from the benefit of a strobe light as opposed to the laser tachometer is you don't have to have a piece of reflective tape mounted on here. You can get you can pay whatever you want to for one of these, a few $100 to a few $1,000. They more or less work the same depending on the application. I like this one because it's small and it fits in a pocket pretty well. And so we're going to use this to do the same thing. I haven't even shut this grinder off. It's running at the same speed. We're going to go in and check it using a strobe light. So when I turn this on, in just a moment you'll see a bright flashing light. Now, how do I know to get it close? What do I know to adjust this thing to? Because I can double the flash rate, double it again. I can divide it in half again. So where would I start? For me, the first place I'm going to look is the nameplate data on the motor. If it says this motor runs 3575 at 60 hertz, if I have it all the way up at 60 hertz or full speed, I know I should be somewhere close to 3575. In this case, we have a variable speed grinder, so I'm going to start up about 3600 RPM, and I'm going to drop that speed down, and hopefully if digital cameras work in our favor, you'll be able to see the change in that. So right now I'm going to run this up to about 3600 RPM because I know that's where I want to start. So we're up there around 3600, and now I'm going to point it at the shaft. In this case, I'll point at this rotating disc and start slowing it down. And what I'm looking for is that image to start changing. Now here, I can start to see that reflective tape or the nut that holds this disc onto the rotor. And it's turning slowly, at least it appears to be turning slowly. Just remember, and you guys in maintenance have heard this for years, just because we freeze this image with a strobe light doesn't mean it's not turning. I've heard stories of people losing fingers because they thought they could reach in here. So let's get a little closer. Right now I'm at 3,315 RPM. Now it may be a different speed than before, but notice as I slow it down more, I can see that nut turning more slowly and more slowly. I can see that reflective tape, and now I can just do a fine adjustment till I stop that image in place. Now, that, if you'll notice there, it's going a little bit up and down. It may rotate a little backward, it may rotate a little forward, and it may stay directly in place. Some of that is just depending on the current, the power that's coming into the building, how good a motor this is in this little grinder. But I know I'm somewhere very close to 3,156 revolutions per minute. So if I cut that in half, notice that I'll see similar, it's a little bit fuzzy here, but it looks to me like it's just as still that way. So you have to play and experiment when you're using a strobe light a little bit. I want to get the right speed. Right here what's happening is it's flashing every 2 revolutions. I won't know that unless I double the speed, and hopefully you can see on the camera you can lock that in very smoothly. If I double the speed again, see how many pieces of reflective tape I see? 2. If I double the speed again, now I see what it appears to be 4 pieces of reflective tape. But there's only 1 there. It's flashing 4 times per revolution, so it makes it look like there's 4 pieces of tape. If I cut that speed in half, I'm going to go back to 2 pieces. So I know from this, if I divide that speed by 2 and make a fine little adjustment, I can lock that speed back in. So what have I based that on? A lot of things. The nameplate data on the motor. If this were on a machine that goes through a gearbox, you might want to do a little quick math in your head to calculate the gear ratio so you know about what the output speed would be. If it's a belt-driven machine, if I've got a 6-inch sheave on the motor and a 12-inch on the fan, I know that the fan's running about half the speed as the motor. If I'm on a VFD controller, I may go back to the control panel. If it tells me it's running at 30 hertz, then I know it's about half the speed it would be at 60 hertz. If it says 45 hertz, then I know it's about 3/4 of full speed. So it does take a little bit of practice, but you can get a very accurate running speed. Now, some cool things you can do with a strobe light that are an aside from doing vibration analysis. I can slightly slow down the rotation of this, and I might look for something like a wobble in the hub. Since it appears to be rotating slowly, I could see that. If this washer were loose or the nut were loose, I might be able to see that. So a strobe light, really for the money, is not only a great tool to get the accurate running speed, but it is a great tool for you doing inspections on equipment as well. So one of the benefits of our one-prod Falcon or the SMC is both units have a built-in strobe light, so you don't have to carry one with you. We're going to start this grinder back up, and we will use the strobe light, in this case in the Falcon. We'll try to find that running speed, same way. So With this strobe light, I have a fine adjustment that steps it up in lot slower, more accurate increments. I have a coarse adjustment which steps it up in fairly quick increments. I have a 2x multiplier. That's to make it go faster. To make it go slower, I have the same thing. I have a fine adjustment, a coarse adjustment, and I have a 2 times divider. So we're going to use this the same way to lock in the running speed on this grinder. So now I'm going to aim my strobe light. Again, I can see it turning slowly. If I hit the 2 times multiplier, that gets me up to about 3,000. So now I use the fast adjustment that really picks it up in a hurry. Now I'm getting pretty slow, so I may want to go to the fine adjustment. And again, I'm just going to increase the speed or decrease the speed until I get that image to freeze. In this case, 3,149.4 cycles per minute is the running speed, or at least really close. If I hit the 2x multiplier, I get 2 pieces of reflective tape, or the image looks like 2 pieces of reflective tape. If I hit it again, I get 4. So if you're out in the field and you see 4 keyways, odds are good this shaft doesn't have 4 keys, it only has 1. If you see that, divide that speed by 2. If you see 2 keyways, or in this case 2 pieces of reflective tape, divide it again by 2, and then you can use the fine adjustment to really lock in a very accurate, that's dead on, accurate running speed. So now we want to get into a laser photo tachometer. Now it's different than the strobe light that we were using with the Falcon earlier, which is just a visible beam strobe light. This is actually a laser photo tach. I'm going to aim it toward this rotating disc on the grinder. We're going to try to get an accurate running speed here. So I'll simply go here on my Falcon. I'm set up to do a balancing job. Before I would do, I'd want to test and make sure I had an accurate 1x by testing my tachometer. So I'll just go into the tachometer, tell it to do a test, and what I want to do is get the tach to fire. So now it's getting some measurements here. I can see that my beam is fairly stable, and I have a running speed of 3,135. So now I have a good, solid, locked-in running speed. Now the difference in using a strobe light, where I might be using this to lock in the running speed, and using a laser photo tach, is I don't have to guess, is this setting at 1 times or 2 times? Do I have to speed it up, slow it down, or any of those type things? I need an accurate running speed. So I don't have a 2x, I don't have a 3x, but I will give you a word of caution on using a photo tach. Most people have a tendency, they think they want to get it up really close, and it's actually one of the worst things you can do, because it can actually count that rotation or count that flash 2 or 3 times or more in one rotation. So you want to get back from it a bit, at least 6 or 8 inches usually, and you may even want to turn it at a little bit of an angle. Even at this angle, about 10 degrees this way and 10 this way, and about 6 or 8 inches away, I can lock in a very solid, very stable running speed. So this is probably, of the 4 ways, probably the most accurate or the most critical to use if you're going to balance this machine. But the good thing about a good, tight laser beam on a photo tachometer is there is no variability about is it at 3 o'clock or 2 o'clock. This will give us a very accurate measurement both in running speed and in angular position, degrees. So that's 4 different methods right there and to get an accurate running speed on the machine.